Hello and welcome back. Alright, in this video we're going to start coding up our algorithms for our expression tree. I'm going to go ahead, so I just created a blank C++ project here in Xcode. I'm going to go ahead and mock up kind of what I want my API to look like. Call it as if I've already implemented it. That way we can iterate over the testing and kind of see what's going on as we go. Okay, so I will be creating a file called expressiontree.h. So I'm just going to go ahead and do a pound include up there so I won't have to do it later. Okay, so down here, go ahead and delete that little boilerplate code it's going to have. Alright, so I'm going to be creating a class called expressiontree. We'll give it a name exp. And it's going to take a string, that's our expression value, as the parameter to the constructor. Okay, so I'm going to write out this expression 1 plus 2 times 4 divided by 2. Okay, that seems pretty simple. We can go through this answer and see what it should be. We know that 3 times 4 should be 12, divided by 2 is 6. Okay, so the next thing I want to do is just do a little output here. We're going to do exp.expression, and that's going to give me back the string result that I passed in. Basically, it's going to hold on to what the user gave me so I can output it later. And then we'll do space equals, and then we'll actually do expression.evaluate. Okay, and then we'll finish it off with a nice little end line. Okay, and so really that is what we're going to do for our main class, or sorry, our main function. Obviously, if we build now, we're going to get build errors that nothing exists and blah blah blah. So let's go ahead and define this main expression tree header file, and we'll come back here and build and make sure all of our errors go away. Alright, so I'm just going to come here, add new file. Let's bring this down so you guys can see it. Do C++ file, and we're going to call it expression tree. Perfect. You see they got added over here on the left side. Alright, now that these are added, I'm actually going to go ahead and close this because I'm not going to be needing the group files over here anymore. So let's double click that, it makes it go away. Okay, so we got a nice little comment boilerplate that Xcode spits out, whatever. So the first thing we want to do in our expression tree is we actually want to do our little header include guards. So pound, if not defined, expression tree, define and if. Okay, perfect. Alright, so now I want to create this class called expression tree. Pretty straightforward. Make sure we get that terminating semicolon, and we'll go ahead and create a public scope section. Alright, so if you remember, if we talk about our trees, we have these things called nodes. Alright, so we're going to need to create a node class. I'm going to call it a struct just because I want everything public by default anyway. And that's going to take in a standard string, and let's just do that for now. And it's going to have 3 components, right? There's the string value that node is holding, that parent node value. So it could be an operator, it could be a number. That's going to be represented by a string. Okay, we're going to call that value. And then we have the left and right node pointers. So we're just going to create a node pointer left and a node pointer right. Okay, so you can see that we already need to go ahead and include our string. So let's go ahead and jump up here and do that. So I also know that I want to create, and then I'm going to be using a stack based on our talk. The other thing I'm going to include is a thing called a map. And we're going to use that to store our operators and the functions that are going to do our adding, subtracting, multiplying, and dividing for us. So let's just go ahead and put that up there right now. Okay, so I'm going to come back up to the constructor of node, and what I'm going to do is I'm going to initialize the values of my node based on the parameters that I've been given. Obviously, value is the only one that's coming in that I'm passing into my node, but I do want to initialize my left to null and my right. Close that parenthesis, and my right to null. Okay, basically I want my nodes to be nice clean objects, and I want my left and right pointers dangling to some random location in memory. Okay, so the next thing I'm going to do is I'm going to go ahead and create the constructor for this class. Okay, expression tree. It's going to take in a constant string reference string, and let's create a destructor for now. Okay, and then remember back to our main CPP. We have this expression and we have these evaluates that we need to do. So let's go ahead and define those, or declare them. So we got evaluate. So what this is going to do is it's going to take in a node pointer, and I'm going to default that parameter to null. And I'm also going to make this function a const function. I think I've talked about const, but if I haven't, putting the const on the end of that member function tells the compiler that I can't change any member variables of my expression tree. So basically it allows us to use constant objects of expression trees in our program somewhere else and be able to call this function on it. And so, since our evaluate function really shouldn't be updating our internal data members of expression tree, that makes total sense for it to be a constant function. Okay. And the other one we're going to do is a standard string expression, and it's going to be constant as well. And what that's going to do is it's going to return the string value that we've been storing based on the constructor parameter that we passed in. All right, so this default parameter right here, the point of this is that I'm going to be calling evaluate recursively. Remember that we're going to start at that parent node, and we're going to be calling evaluate on the left side, and we're going to take that evaluation, apply it to the operator, and evaluate the right side, take that to be applied to the operator as well. So this is just an easy way for me to not have to write another function that's called evaluate helper or whatever. I can say, hey, evaluate at this node and give me back the result. This also allows me to, hey, you know what? I need to debug my code in my program, and I want to evaluate what's happening at a specific node that I want to provide. So this allows the user or us to do that as well. And so if you don't provide a parameter into this function, then it's going to assume the compiler will make that parameter be null for you, since that's what we've said that the default value should be. Okay. The other two things I want to do right now are create a private section. And inside here, we're going to create a node pointer, which is going to contain the root node of our expression tree. And we will create a variable to hold our actual expression value that the user passed in. All right, so that's all I'm going to do for now. Let's go ahead and jump over into the C++ file. You can see, okay, great. We got the The header file coming in, let's go ahead and come over here and copy over these includes because we're going to need those here too. Technically we don't since they're getting included, but it's good practice to actually include the things that you're going to be using. So let's jump back over to our header file. We need to grab all of these items so that we can define them in our C++ file. So let's remember to scope them in. Okay, so the expression tree, all we're going to do is initialize expression with the stir value, and that's all we're going to do for now. The destructor, we're not going to do anything in it right now. Okay. Our expression tree evaluate, I forgot my colons. Okay, evaluate, this is a double. What we're going to do, return 0. We'll come back to that after we create our tree. Expression, all we're going to do is return what that user entered in. Alright, so now if we build, we still have 4 build errors. Let us go look and see what they are. Expression tree referenced from here. Did I forget some functions? So we're looking at those 4 build errors. I got 1 error up here. We build. Alright. So these are link errors. What this is telling me is either there's something funky with my compiler or this file isn't really in my project. So let me open up my file view again and actually expand this piece. Yeah, I must have... Let me see what my default file is here. Drag this down so you guys can see what I'm doing in case you run into this. Oh, interesting. I should have added it to it, didn't. But it didn't. Okay, so the problem is that if you look up here at my code, you can see that main CPP is checked as part of this target, but my expression CPP file for some reason didn't get checked. So if we check that and then we rebuild, oh yay! So I don't know what happened there with Xcode. It got a little funky. I must have hit a key or didn't realize that I didn't actually include that expression tree code file into our project. All right, so I'm going to go ahead and double click to close that. Wrong one. Okay. All right, so we're back into our main file here. We built. We are good to go. Bring up our little run dialog, and we hit Command R to run our compiled program, and we can see in fact that, hey, we did output the expression that the user passed in. That's great. But our code thinks that that evaluation is 0. Well, that's obviously the case because we told evaluate to just return 0. Okay, so I'm going to do a little bit more setup code, and then we will break this video and get some more work done. So let's get our header file fully implemented out with everything that we want, and then I'll stub in our C++ files. Okay, so we have our nodes that we need. We have a few of the functions. We don't really have everything that we want, though, because we don't have any way to evaluate the function, really, other than that evaluate call, but we don't really have a way to take the string that's given in and turn it into a tree so that the evaluate function can do any work. We also haven't defined what our operator function calls look like either. So let's go ahead and do that first. So I'm going to define my operators inside my expression tree. I'm just going to keep it all in here, keep it kind of simple because it's really all related anyways. It doesn't make sense to break them out into different spots. All right, so I'm going to create a static method, and so what that means is that regardless of how many instances of expression tree, there's only a single representation of this function, and this function doesn't actually have access to the private member data. They're not needed as the operators are already passing in the values that we care about anyways. Okay, so the operator is going to return a value of double, and we're going to create the add one first. double X, double Y, and I'm going to go ahead and implement them in place. So X plus Y. We're going to do this for all four that we care about. Subtract double X, double Y, return X minus Y. And let's just go ahead and copy and paste. And we'll do multiply. Change that plus to a star. And divide. Change that minus to divide. Okay, so we've defined our operators. Perfect. That's all of the functions that I actually want here. I'm going to go ahead and actually move these down into a protected section, as they are not needed to be public, or they're not needed to have public exposure. Okay. All right. So the next thing I want to do is I want to create a map that's going to hold all the different operators that I care about. And inside that map, I'm going to have it have a key of the operator, and I'm also going to have the key be, sorry, not the key, the value be, have two pieces of information inside of it. The first piece of information is the precedence of that operator. The second piece is going to be the a pointer back to the functions that we just created right here, that we can call in order to do our work. So we're actually going to learn how to create a function pointer. It's just a pointer to a piece of code that we want to have executed. So let's go ahead and create our map. All right, so I'm going to do typedef, standard map, and we'll do standard string. Since all of our values are strings, you could have a char because operators are a single character, but for ease of use in our algorithm, I'm actually going to go ahead and use a string there as the key. And then I'm going to create this thing called the operator info, and we're going to call it an operator underbar map. Okay, so right above here, we're going to define what this operator info is. And so it's just a struct, and remember it has two things. It has the int precedence, and the next piece that it has is going to have that function pointer. So we're going to call that function pointer, we're going to create a type for it, operator func, and we'll just call the parameter func. And then right here, we'll create a typedef. And so the way that you define a function pointer is you essentially do the return value, and then inside parentheses you have star and the name of the function pointer. Basically this is going to be the type name, operator, not operator. And then you do another parentheses just like the function, and you specify the parameter types. Alright, so what this does, I know this is really weird syntax, what this does is it creates a type for us. That type is called operator func, and the type of is a pointer to a function with this signature of a return type of a double and two parameters that are doubles. Okay, so if you look back up here, you can see that's exactly what this prototype is. If you just basically take out these parentheses and put in the word add, then you can see that that function signature looks exactly the same. Okay, so I know that's a little bit cryptic, but you know, that's kind of fun. Okay, and so the next thing we want to do is we're going to create a helper function that's going to take the string and convert it into an expression tree for us. And so we're going to call that helper function from string. And it's going to take a constant standard reference string str. Okay. And that is going to, well, so the other thing we need to do is we have this static map right here, right? When we don't have a variable for it, so let's go ahead and create one. It's going to be static, It's going to be type operator map, and it's going to be called operators. So what this does is that, hey, you know what? All of our expression trees share the same map of operators, because there's no point in creating a new map for every single operator out there. Obviously, each one shares the same set of data. Okay, so with that, we're going to go ahead and wrap up this video. In the next video, we'll continue on from here and go into the implementation of each one of these functions. So with that, thanks.